Okay, now let's work with this problem. Or for in equals to the sum between k and n of n e to minus n over k, everything over k squared. We want to find the limit of in as n goes to infinity. We can do some study of this one, and it's going to be difficult, but the aim for it is to make sure that we use the Riemann sum. Okay, let's write it in a Riemann sum. Let's make it look like some Riemann sum. Okay, so we have in is to the sum of k going from 1 to n. So here e to minus k over minus n over k, I can divide and multiply by n squared. So it's going to be n squared, and n. Now I have my 1 over n. I can take it to the front because it doesn't depend on the sum now. So here e to minus n over k over n squared. Okay, now this looks like some Riemann sum with I have 1 over n that I need. Now I can take the function, so this is n. So if we let xk to be k over n, so this is going to be minus 1 over k, xk. Okay, so the limit now, the limit as n goes to infinity of in is going to be the limit of 1 over n, the sum k from 1 to n, e to minus we call this one x sub k. It's 1 over x sub k because it's minus n over k over x sub k squared. And from here I can deduce that because if I use these subdivisions, xk being a plus k b minus a over n, with a is 0 and b is 1, delta x is 1 over n. And therefore my integral is between 0 and 1 of e to minus 1 over x squared dx. But this is an improper integral. So to compute this one, I need to compute the limit as t goes to 0 plus of t1, integral between t and 1 of minus 1 over x squared dx. The good news is I know a primitive of this one. So the limit, so this one gives me the limit as t goes to 0 plus of e to minus 1 over x between t and 1. Okay, I need to compute first. So I'm going to have e to minus 1 minus e to 1 minus 1 over t, but with the limit as t goes from 0 plus, it's going to be 1 over infinity, which is 0. So it's going to be 1, it's going to be e to minus 1 or 1 over e. Okay, so this is my limit as t goes to 0 plus. Okay, so the integral is going to be 1 over e. That means this limit here is 1 over e if we use Riemann sum, or e to minus 1. Okay, so we had to try to write it in Riemann's formula, Riemann's, make it look like Riemann sum, and it's a Riemann sum, but it's generalized, so to make sure that we get the correct result. And I think that's all we need for this video.